All right, ladies and gentlemen, welcome to lesson 1.5, your fifth installment, segments and their measurements. And so what we're going to be doing is measuring segments and adding segment length. I probably reminded you this in class, but if you don't have a ruler, please get one out so that you have it to work with. We're going to start with our vocabulary. Coordinates, the coordinate is the real number that corresponds to a point, is the coordinates of that point. So that's our x comma y. And that's what we're used to seeing from Algebra 1. We're also going to talk about the distance. Distance is the absolute value of the difference of the coordinates of a segment in point. And now we haven't talked about absolute value very much this year, but we will be talking about it tomorrow in class. But remember, absolute value is just the distance from 0. And so what absolute value tells us is that our answers will always be positive. That's what we know about that. And then length is just another name for distance. So if we talk about what's the distance between the two endpoints, you're finding their distance. If we ask you to find the length, you're finding their distance. It's just a way of measuring. If we take a look between, kind of a weird word to define as I went through and saw that I had it in there, but I think it's crucial for us to have that understanding in order to use a couple of our postulates. But what we have here is if there are 3 points and they are collinear, then 1 point is between the other 2. So for example, if I've got 3 collinear points, I'm going to put A on there, I'm going to put B on there. If I'm going to put C on here, C is going to have to end up somewhere, and so B ends up being between. I could have done A, should I pull this down a little bit? A, B, and if I put C here, I still have a point that's between those. So anytime you have 3 collinear points, one's going to have to be in between them. And then congruent segments are just segments that have the same length. Alright, so here's our postulate 5, segment addition postulate. And so what this says, that if B is between A and C, so B is that between point, then we know AC, the segment from A to C, is the same as AB plus BC. We can take those 2 smaller segments and put them together to make the larger segment AC. So if I know B is between A and C, then AC is AB plus BC. So I start with knowing B, and then I can do segment addition. The other thing you can do with postulate 5 is that if I know AC is made up of AB plus BC, then I know B has to be between them. I can put those points in order on a number line or on a line, make them collinear, and I know I would have to go A, B, and C, because AC is the smaller segment AB and the smaller segment BC being added together. So your follow-up is, what is the relationship between the 2 parts of postulate 5? I want you to do a little bit of thinking, write something down. This is really going to be what we kind of kick off class with on Monday, are these 2 parts of postulate 5, going back and looking at that. So this will be done. This will be a check-in class problem. So you need to think and write something down, but we'll check it together in class. All right, example 1, finding the distance between the 2 points. We're going to be measuring on there. So we're going to measure the length of AC. And BC. So those are the 2 things that we measure. We know that point A lines up with 0, and we know point C lines up with 87 millimeters. So what this is this is 1 centimeter in the larger hash mark. Each of these little ones in blue is a millimeter. There are 10 millimeters in 1 centimeter. So when they talk about wanting to measure in millimeter, I'm counting 10, 20, 30, 40, 50, 60, 70, 80, 5, 6, 7. So it lines up with 87. So to find the distance, I take 87 minus 0. I took C minus A. These brackets are for our absolute value. 87 minus 0, the absolute value of that is just a positive 87 millimeters. If we take a look at point B, it's lining up with, right here, that's 66. And point C, we know, lines up with 87. So to find that, like I said, we're using our absolute value. So we're going to take 87 minus 66, and that leaves me with 21 millimeters. So this is the point. The next 2 slides in here are our checkpoints. I can't measure these on the screen for you guys because the way they come into the screen, they're larger. So once again, these will be ones that we check in class. I should be able to put these up on the document camera, but I'm expecting you over the weekend to find a ruler. We were told to use one on Friday, and so you should have these 4 measurements. Look closely though, make sure you're paying attention. 1 through 3 is the nearest 1/8 of an inch, and we'll have some measuring in inches in class on Friday, and then the nearest millimeter for 3 and 4. All right. So now we're going to use the map to find the distance from Athens to Albany. All right? It looks like that's the state of Georgia, I believe. Pull off the map. But because 3 cities lie on a line, we have Albany, Macomb, and Athens. They all line on the line. We can use what's called the segment addition postulate. I can take 2 smaller segments and add those together to make a larger segment. So I know Albany, or Athens to Macomb, AM, is equal to the 80 miles. And I know MB, Macomb to Albany, is 90 miles. That's the information I'm pulling off of the map here. So AB, from the top Athens down to Albany, or Albany to Athens, is the 2 smaller segments. It's the 80 AM and then the 90 MB, so that's 170 miles. So our answer here, the distance from Athens to Albany, is 170 miles. Notice, ladies and gentlemen, we're making sure that you include labels with this, so we have 170 miles. All right, now what we're going to do is find distance by subtracting. When we said adding segments, you should know that subtracting goes right along with that. So what we want to do is we want to use the diagram, use all the information they give us to find EF. We're looking for this right here. So hopefully you recognize that we have this segment addition. We have these 2 smaller segments. Give me just a minute here, guys. I lost my tools. We have these 2 small segments here. And here to add together. So when we look at that, DF from D to F is made up of DE and EF. This is the big segment, and this is equal to the 2 small segments added together. That's what your segment addition is. What we're going to do now is start substituting values in for DF and DE. DF is what I have. DF was this top one, so I know DF is 16. DE is what I have is 10, but I don't know EF. Now I want to solve. We're using basic algebra, so we're going to subtract 10. And then this could just be mental math, but we know that EF is 6. We don't have any units here, so all we can do is call it 6. So we have a checkpoint here with these problems that we're going to take a look at. I would guess most of you could do that, so we're finding the unmarked length. So for this one, we know AB, we know BC. The unmarked length we do not know is AC, so that's what we're trying to find here. So AC is equal to AB plus BC. Substitute, what do we know? We know AB is 14, BC is 6, so when we add those together, we get AC is equal to 20. Once again, there's no units there, so that's the best we can do. When we take a look here, we've got SR, that's our big segment, is equal to, we have a smaller segment, ST, plus our another smaller segment, TR. Substitute in the values that we know. We know SR is 23. We know ST is undefined for us yet, or unmarked, and TR is 15. So here's where we're going to have to use our subtraction. When we subtract 15 from each side, we get ST is equal to 8. So when we take a look at example 4, deciding whether segments are congruent, we go back to the definition of congruent segments. They have the same length. So for a horizontal segment, if it's going across, so this is our horizontal segment, we're going to subtract the x coordinates. So we're going to take a look at x. Remember, our ordered pairs are x comma y. So all of our ordered pairs are x comma y. So we're going to take negative 3 minus 1. Now when we take a look at that, negative 3 minus 1 is negative 4, but I'm taking the absolute value of that. So the segment length of DE is positive 4. For my vertical segment, vertical is going up and down, I'm going to subtract the y coordinates. So that's going to be 1 minus a negative 3. 1 minus a negative 3 is 4, and the absolute value of 4 is 4. The reason that we use the absolute value there is now we can subtract in any order. If you looked at this and said I want to start from G and go to F to measure my segment, if you did the absolute value of negative 3, and then you minus 1, you would have gotten the absolute value of negative 4, which is still 4. So regardless of which direction we choose to look at our segment to start finding its length, because we're taking the absolute value, we're always going to get the same answer. All right, so it's our last checkpoint. We're checking a couple of things here. Can we plot points, draw in segments, horizontal or vertical, and then decide whether A, B, and C, D are congruent? I'm going to do number 7. 8 is going to be a check in class. All right, but we'll do number 8 together. A is negative 2, 3, so negative 2, positive 3. B is 3, 3, so 1, 2, 3, 1, 2, 3. And we were told to check the length of AB. C is negative 3 and positive 4, 1, 2, 3, 4. And then D is in my book here, and I feel like there's a typo somewhere. Oh, this should be a negative 3. My negative 3 wasn't showing up. So this should be negative 3, negative 1. Hopefully you guys have a negative 3 in your book for both of these. We should probably label our points. This is D. This was C. This was our B. And this was our A. So that's what we're looking at. When we look at AB, because it's horizontal, we look at the x coordinates. So we're taking negative 2, the absolute value, minus 3, that's going to be -5, which is 5 spaces. Now, some of you might have said, Mrs. Wood, I can count 1, 2, 3, 4, 5. Exactly. That's the nice thing about it being visual. If I don't give you graph paper, you have to be able to work with those coordinates. CD, if we take a look at CD, that's our vertical line, and we said we're going to subtract our y coordinates. Notice in these, it doesn't do you any good to subtract your x coordinates because the x's are the same, so we'd get 0. So what we're doing is we're taking 4 minus a -1, so we're looking at that absolute value. 4 minus a -1 is 5, and then we have a length, the absolute value of that 5 is 5. And so once again, we could have said, Mrs. Woodard, 1, 2, 3, 4, 5. Yes, those two should match. If your subtraction, if you're taking the difference of those coordinates and taking the absolute value, and the answer you're getting for this does not match your counting, then, ladies and gentlemen, you were doing something wrong. But we just did a whole lot of work, and we still haven't finished our checkpoint. Decide, are A, B, and C, D congruent? And so because we have a length of 5 and a length of 5, we would say AB and CD are congruent. All right? We're going to save number 8 for you to do in class as a checkpoint. And have a good Sunday, good weekend.